In this video, I'm going to show you how to solve a set of questions that don't provide an explicit formula. Instead, they give us two descriptions, and we have to go from there into an equation. The question says, the kinetic energy of an object is the energy that the object possesses due to its motion. We can sort of ignore that. Then says kinetic energy is equal to half of the product of the mass and the square of its velocity. So I could write kinetic energy is equal to half of the product of its mass times its velocity squared. And I could simplify this into the following. K equals mv squared over 2. M stands for mass, v stands for velocity. This little key isn't really required, but it can be helpful as you do more work. The next statement says, the momentum is the quantity of the motion of a moving body measured as a product of its mass and velocity. So I could write momentum is the product of its mass and velocity. So since I have m equals mass and v equals velocity, I can just write momentum equals m times v. Number 7. If two bodies, A and B, have equal kinetic energies, and the mass of A is 4 times as much as the mass of B, what is the ratio of the momentum of A to that of B? Okay, so we have two pieces of given information. A and B have equal kinetic energy. I can write kinetic energy of A equals kinetic energy of B, but I'm going to write it in shorthand. K subscript A equals K subscript B. And it also says that the mass of A, so mass subscript A, is equal to 4 times the mass of object B. Okay, now since the two kinetic energies are equal, I'm going to write that in the expanded notation. M A times velocity A squared over 2 equals the mass of B times the velocity of B squared over 2. And then I am going to replace anything that says mass of A with 4 times the mass of B. So the first equation, I'm going to write that as 4 times the mass of B times the velocity of A equals, over 2 equals the mass of B times the velocity of B squared over 2. I'm going to multiply both sides by 2. And divide both sides by the mass of B. And, got the square over here. And now I'm going to find the square root of both sides. So the left side is going to become 2v equals v of b. And so this seems like another useful fact. Okay, so now that I've listed out a bunch of facts, I am going to try to solve the question. I don't think I can make any of these equations any simpler, so this is a good time to actually see what the question is asking for. They're asking for the ratio of the momentum of A to that of B. So momentum, I'm going to give momentum a variable. I'm going to write momentum equals P. In most physics textbooks, momentum is traditionally written as P. So we know that they're asking for the momentum of object A to that of B. So the momentum of A, it's a ratio, so it's a fraction, so we can write momentum of object B in the denominator. And momentum is equal to mass times velocity. So for the momentum of object A, it's going to be the mass of object A times the times the velocity of object A. And for the rest of the ratio or fraction, the denominator is going to be mass of object B times the velocity of object B. Now, since this is what they're asking for, I'm going to plug in as many of these variables with equivalent variables that can be cancelled with each other. So, for example, the mass of A, that can be replaced with 4 times the mass of B, according to this statement over here. And the velocity of object B in the denominator can be replaced with this statement over here, which says that the velocity of object B is equal to 2 times the velocity of object A. So I'm going to rewrite that fraction with these replacements. So mass of object A, I'm going to write that as 4 times the mass of object B times the velocity of object A over the mass of object B times the equivalent of the velocity of object B, which is 2 times the velocity of object A. And then I'm going to simplify as much as possible. So the mass of object B can be reduced from the numerator and the denominator. And the velocity of object A can also be reduced. So now we have 4 over 2, or 2, which is answer letter C. Okay. Now question number 8 says, if two bodies A and B as described above have equal momentum, what is the ratio of the kinetic energy of A to that of B? So keyword as described above. They have equal momentum. So their kinetic energy, and they're asking for the ratio of the kinetic energy of A to B. Now 7 says the kinetic energy is equal. So if we were going off of that information, then the answer would just be 1 to 1. This question isn't very clear, but we can deduce that the fact that they have equal kinetic energies is not going to apply to this question. So we can erase the stuff that's all deduced from the fact that they have equal kinetic energies. So we can erase this statement over here. Ka equals K of B. Which means we can also get rid of anything where we see the squaring. So that can be gotten rid of. And this information over here as well. So the only thing that we're keeping from the first question is the fact that the mass of A is 4 times as much as the mass of object B. Okay, so they have equal momentum. So P of A is equal to P of B. And then I'm going to rewrite that with mass and velocity. So mass of object A times the velocity of object A equals the mass of object B times the velocity of object B. And then I'm going to replace whatever I can with this fact over here. So mass of object A is equal to 4 times the mass of object B. So I'm going to write 4 times the mass of object B times the velocity of object A equals the mass of object B times the velocity of object B. And in order to make this equation simpler, I'm going to divide both sides by the mass of object B. So this is getting cancelled and this is getting cancelled. And so now I have 4 times the velocity of object A equals the velocity of object B. Okay, so this seems like a pretty useful fact. Now that I've taken the assumptions and reduced them as much as possible into useful facts, I am going to see what the question is asking for. So it's asking, what is the ratio of the kinetic energy of A to that of B? So again, fraction, they're asking for kinetic energy of A to the kinetic energy of B. The kinetic energy is equal to half times the mass times velocity squared, or mv squared over 2. So I'm going to rewrite the mass and velocity with the subscripts for each one of these kinetic energies into a fraction. So mass of A times the velocity of A squared over 2 over the mass of B times the velocity of B squared over 2. And then I'm going to multiply the top and the bottom by, or this entire fraction by 2 over 2 to get rid of those 2 in the denominators in both the numerator and the denominator. So I'm just going to erase the division by 2. Again, I just multiplied top and bottom by 2 over 2. Okay, now I'm going to replace some of these variables with their equivalencies so that I can start crossing out variables. So looking at this factor here, it seems like it's a good idea to replace all the velocity of object B's with 4 times the velocity of object A. But one of the issues here is that the velocity over here is getting squared. So I have to square this equation on both sides. On the left side, it's going to become 16v equals v, and the v's gets squared as well. And so now I can replace this with this. And I'm going to write that right over here, right below it. So this is all equal to mass of object A, which can also be replaced with this factor over here. So I'm going to replace that with 4m mass of B times the velocity of object A squared over the mass of object B times v squared b, which is equal to this equation over here, and this factor over here. So 16 v a squared. Okay, and now we can start crossing out factors that appear in both the numerator and the denominator. So the mass of object B, that can be cancelled out. The velocity squared, that can be cancelled out because they're the velocity of object A squared. And now we have 4 over 16, which is equal to 1/4. And that is the answer for this one, 8. B. Okay. So again, when I started with this question, I didn't really know in which direction to go. I just listed out all the facts, and then I tried to simplify those facts. And I tried to simplify them in any direction, really. As long as it's simpler than the original fact, it's going to be useful, or it's likely to be useful. And you can't really tell how it's going to be useful until you see a situation where you can plug in that information. It's sort of like going to a project with a toolbox that just has as many tools as possible instead of looking at the problem and then trying to figure out what tools you need. It's better to just come up with all the tools and then see which ones can be useful. And that about wraps it up.